In this lesson, we'll be discussing how to evaluate the limits of radical function. Radical functions are functions that involve roots or complex numbers. And to solve radical functions, especially when they are in binomial forms, you need to multiply the root by its conjugate. And let's take conjugate of a radical expression. If we have this expression a plus b, root b, a plus root b, what do you think will be its conjugate? Now the conjugate of these will be flipping the sign. We are going to have a minus root b. And if you have to multiply the expression by its conjugate, what we are going to have is a plus root b multiply a minus root b. We'll see that this is in the form of a minus b squared. So it is in the form of difference of squares because a minus b squared is a minus b multiply a plus b. So this can be written as a minus root b squared. And if you break this down further, you are going to have a square will give us a square and minus root b square will give us b, because root b is the same thing as b to the power of 1 over 2. If you square it, this will cancel this. We are left with b. So this gives us the final breakdown. However, this doesn't lead to anything yet. We are just exploring how to break down a complex radical expression. If you understand conjugate, you can pause the video and try this out. What do you think will be the conjugate of root x minus 2 plus 5 and root x plus root x plus 1, and the final one, root x minus 2? Let's start with the final one. This has no conjugate because it is not in binomial form. This, the conjugate, will give us root x minus root x plus 1. And the conjugate here will give us root x minus 2 minus 5. So if we understand the concept of conjugate, let's dive into evaluating the limits of radical functions. If you are given to evaluate the limit as x approaches 4 of root x minus 2 all over x minus 4. Let's do a direct substitution and see if that will give us a definite answer. If we have root 4 minus 2 all over 4 minus 4, root 4 is 2, 2 minus 2 is 0, and 4 minus 4 is 0. This is indeterminate. So we have to use the conjugate, and we can find that the numerator is in binomial form. So we can have the limit as x approaches 4 of x minus 2. So we are multiplying both the top and bottom by the conjugate. So we are going to have multiply root x plus 2 all over x minus 4 multiply root x plus 2. And this will give us the limit as x approaches 4. Now you remember the top is in the form of a minus b. Remember, a minus b will give us a minus b square will give us a minus b multiply a plus b. And in this case, root x minus 2 will be a, and root x minus plus 2 will be b. So let's rewrite the numerator as difference of squares. We are going to have root x minus 2 squared all over x minus 4 multiply root x plus 2. And this will give us the limit as x approaches 4. Now root x squared will give us x. You still remember how we got that? Root x is the same thing as x to the power of 1 over 2. If you square it, 2 cancels out 2. We are left with x. So x minus 2 squared will give us 4 all over x minus 4 multiply root x plus 2. X minus 4 will cancel out x minus 4. So we will have the limit as x approaches 4 of 1 all over root x plus 2. So as x approaches as x approaches 4, the answer finally will be 1 all over root 4 plus 2, and root 4 is 2. 2 plus 2 is 4. So this is our final answer. As a matter of practice, you can try your hands on the next example. Pause the video, and when you return, you watch the solution. If you are given to evaluate the limit as x approaches 0 of root 4x plus 1 minus 1 all over x. Let's try again with direct substitution. If we substitute the value of x, we are going to have 4 multiply 0 plus 1 minus 1 all over 0. and this will give us root 1 minus 1. Root 1 is 1 minus 1 is 0 all over 0. So this is indeterminate. So the right solution will be we multiply both sides by the conjugate of the numerator. So this will give us the limit as x approaches 0 of root 4x plus 1 minus 1. Multiply the conjugate, which is root 4x plus 1 plus 1 all over x. Multiply the conjugate of the numerator, root 4x plus 1 plus 1. Remember, the top is the difference of squares, so we can rewrite the numerator to have the limit as x approaches 0 of 4x plus 1 root 4x plus 1 minus 1 square all over x multiply root 4x plus 1 plus 1, and this will give us the limit as x approaches 0 of root 4x plus 1 will give us only 4x plus 1 minus 1 square will give us 1 all over x multiply root 4x plus 1 plus 1. Now, if you are wondering how we got from root 4x squared plus 1 to 4x plus 1, now let's have the root of 4x plus 1. Root 4x plus 1 is the same thing as 4x plus 1 raised to the power of 1 over 2. Now, if you square this, you have 2 will cancel out 2, so we'll be left with only 4x plus 1. So, and this will give us the limit as x approaches 0 of what we'll have left at the top will be plus 1 minus 1 will be 0, right? So we are left with only 4x all over the denominator, which is x multiply root 4x plus 1 plus 1. If we go further to solve this, we will have that x will cancel out x, so we will have only the limit as x approaches 0 of 4 all over root 4x plus 1 plus 1. Now, as x approaches 0, we substitute the value of x. We replace x with 0. We are going to have 4 all over root 4 multiply 0 plus 1 plus 1. And this will give us, this will give us 4 all over 4 times 0 will be 0. So we are left with only 1. So we are left with root 1 plus 1, which will give us 4 all over root 1 is 1 plus 1, 2. And our final answer will be 2. Let's take the final example. in this series. If you are given to evaluate the limit, and you can pause the video and try this out. Evaluate the limit as x approaches 1 of x squared minus 1 all over root x plus 3 minus 2. So how do you go about solving this? Let's try direct substitution. If we try direct substitution, at the top we are going to have 1 minus 1 because 1 squared is 1, minus 1 is 0, and 1 plus 3 is 4, so we have root 4. Root 4 is 2, 2 minus 2 is 0, and it will be indeterminate. So direct substitution doesn't work. Let's use the conjugate of the denominator. We see that the denominator is in binomial form, so we can have the limit as x approaches 1 of x squared minus 1 multiply the conjugate of the denominator, which is root x plus 3 plus 2 all over root x plus 3 minus 2 multiply its conjugate, which is root x plus 3 plus 2. This will give us, if you look closely, at the top we have difference of squares, alright, because s squared minus 1 squared is the same thing as we are having here, and 1 squared is 1. So this is difference of square, which is x minus 1 square. And x minus 1 square can be written as x minus 1 multiply x plus 1. Okay, so let's have that. And for the denominator, we see it's also difference of square. Let's also rewrite that. We are going to have the limit as x approaches 1 of x minus 1 multiply x plus 1 multiply the conjugate, which is root x plus 3 plus 2 all over the denominator is difference of square, which is root x plus 3 minus 2 square. If we go further to break down, we are going to have the limit as x approaches 1 of x minus 1 multiply x plus 1 multiply the conjugate, which is x plus 3 plus 2 all over. Now for the denominator, if we expand this, root x plus 3 square will give us x plus 3 minus 2 square will give us 4 minus 4. So this will give us the limit as x approaches 1 of x minus 1 multiply x plus 1 multiply its conjugate, which is x plus 3 plus 2 all over x plus 3 minus 4 will be x minus 1. So we are going to have x minus 1 left here, and we see this can cancel out, so that we have finally the limit as x approaches 1 of x plus 1 multiply root x plus 3 plus 2. As x approaches 1, let's replace the value of x with 1. We are going to have 1 plus 1, that will give us 2. So we have 2 multiply root 1 plus 3 is 4 plus 2. So root 4 is 2. So we are going to have 2 multiply 2 plus 2, which will be 8. 2 times 4, which is 8. This is our final answer. If you find the video helpful, please subscribe to our channel, like and share.